Welcome back. Please do follow me on YouTube for lots of exciting information pertaining to electrical engineering, process control, as well as instrumentation. Today we're going to go into a slightly different direction, and we are going to speak about the Dahlin algorithm. Now, this algorithm is going to be a model-based technique, and it is based on an approximation of our process. It is going to differ in one very important aspect, and that is that it is going to be a sampled data algorithm rather than a continuous algorithm, and you'll find that in the demonstration that we're going to go and do very, very shortly. Now, you and I don't have to know how the algorithm is designed or how it gets used inside the controller. We've just got to get the system up and running. So I've gone straight to my simulator and I've gone and opened it up as a Dahlin algorithm and set it up for us to go and do the process. Now, as always, I need to have my process in manual, and I can go and run it. This is going to be a self-regulating process, which many of our processes are. And so what I'm going to do is give it a step output. I will switch on the data monitor, and you can see that my output is sitting at 35 and the process variable is at 52.5. So we'll just go and increase the output by 10%. I'll take it up to 45% and try and do it on the line, and we'll allow the process to go and self-regulate, and from that we can collect the right information. It looks like with an output of 45, the process variable has gone up to 67.5. So I can go and capture that image, just pause it, and now we can go and capture it and get the three elements of our model, which are by now very, very simple and something that we have done on numerous occasions. So we're going to go copy that quickly, get to a blank page, paste it down, and do what we have to go and do. Well, in this case, the very first thing that we need for our model is going to be the gain of the process, and the gain of the process is calculated as the change in the process variable divided by the change in the output that would have caused it. Now, the process variable would have changed from 52.5 to 67.5, which would have been 15%. And the output would have changed from 35 to 45, which would have been 10%, and that gives me a value of 1.5. Then we have to go and look at the dead time of the process. That's the time that elapses from when the output changes until there is a noticeable change in the process variable. It looks like about, we're working on a scale in minutes, it looks like about 8 minutes. So I can go and write that down as 8 minutes. We need to have the time constant, the rate of change of the process itself, and that is the time that elapses from when the process variable starts to respond until it goes to about 2/3 of where it is going to go, and possibly looking at one complete block over there. So I'm going to use a value of 5 minutes. Now, with the Dahlin algorithm, there is one other important aspect that we need to go and get, and that is going to be our sample period, and that sample period must just divide into the dead time without any remainder. In other words, just look at that, we can use a value of 1 or 2 or 4 or 8. It must not have a remainder, otherwise it does not work at all. And that is it. We go back to our system and we go and set it up. In the tuning algorithm, it's going to say to us, what is the gain of the process? We calculated 1.5. Our time constant was going to be 5. The dead time that we had was going to be 8. And I'm going to sample it every 2 minutes. 8 is going to go, at least 2 is going to go into 8 without any remainder whatsoever. And my book was lying on the keyboard and it wouldn't allow me to put in the sample time. I can now go and type it in. Now that's going to have a value of 2 that I've gone and put in. And that is it. Put the process into automatic, and now we can go and run it. And I want you to have a look at that output. You can see how the output is actually going to jump from time to time as we try and set up the process. I'm going to just change that set point of mine, and you can see how the output jumps up and down to give us the process that we would like to go and achieve. And maybe we can go down one more again just to see what we can achieve. Look at how that output jumps to a new value, waits for its sample period, jumps to a new value, waits for its sample period. Again, you and I can go and change the aggressiveness of the process. I could possibly take that down to about 5. And what you will find out is that the process is going to be slightly more aggressive. And you can make it even more aggressive than that if you so desire. That's going to get us to the set point. Let's go and possibly take it down to a value of 2, make it even more aggressive, and see what we can come up with. It still uses the same sample period before it goes and adjusts the output. And that is it. That is my demonstration of a Dahlin model. Great. Let's go and wrap all of this up. You have got all of my contact details in case you need anything. Please do feel free to have a look at some of the courses that are on offer. Thank you so much, and goodbye.